So let's unpack this. Looking at the source for today's deep dive, well, it feels a lot like examining a single lug nut on a Formula One car. It seems, incredibly small, maybe almost insignificant, but it is actually the linchpin of this sprawling high-stakes operation. Welcome to this custom deep dive where today we are zooming in on a very specific piece of tech. It is a replacement cooling fan module for an NVIDIA chassis.
Yeah, it's a highly specific starting point, right? But our goal here is to really crack open the broader economics and the architecture of commercial audio and video distribution. We want to show you why enterprise-scale infrastructure basically lives or dies by a tiny, unglamorous fan.
Right, because looking at the specs, this is just a 24-volt, 1.2-watt fan. Our source, HDTVSupply, they specifically note they have 50 of these Vitec C1210-FAN modules in stock for U.S. shipping, which really makes me wonder, why does an IT director care about this specific listing? I could buy a cheap 24-volt fan online right now.
Oh, absolutely you could. But the thing is, you aren't just cooling a basic desktop computer here. These AvediaStream C1210 chassis, they are pushing uncompressed high-definition video data constantly.
Wow, okay.
Yeah, and when a system is routing that much data, those processing chips basically act like space heaters. So if that thermal load isn't exhausted immediately, the silicon literally cooks itself.
It just fries. So
Yeah.
heat is the ultimate enemy of AV processing gear.
Precisely. And, well, that dictates the entire engineering approach. High-end enterprise tech is specifically designed for what we call modular failure.
Modular failure. Wait, meaning they build it to break?
Well, not to break, but they know the moving parts, like fans, are going to degrade and fail eventually. It's just physics. So by making them exact hot swappable replacements, IT teams can pull out a $20 cooling mechanism in seconds.
Ah, right. Without having to rip out a $5,000 piece of networking gear.
Exactly. You protect the expensive, static brains of the operation by sacrificing the cheap moving parts.
That makes total sense. So replacing a low-cost module saves the high-end chassis.
Yeah.
But who is actually stockpiling these specific parts? Because when you look at the vendor, HDTVSupply, the sheer scale of this supply chain becomes incredibly apparent. They are a 25-year-old global vendor with over 10,000 positive reviews. But their catalog, it is not just replacement parts.
Far from it, yeah. They are building extensive AV over IP setups. We are talking about enterprise-grade networks that use standard internet protocols to distribute audio and video across entire buildings.
Right, like the source highlights their Wolfpack systems. They can connect up to 160 TVs.
Oh, easily.
And they build these massive 64 by 64 4K matrix switchers. Just to visualize that for you, that means a system taking 64 different video inputs and routing them to 64 different screens simultaneously.
And, they are outfitting giant commercial sports bars. They are securing government contracts with GSA and TAA-approved purchasing. The contrast here is what is really compelling to me.
How so?
Well, you have these colossal high-stakes installations. These are places where a dark scream during a championship game or a lost feed in a secure government briefing room is just catastrophic.
Yeah, heads would roll.
Yeah.
But that entire operation relies entirely on thermal management to keep running.
Yes, exactly. Those flashy installations only survive because the supply chain logistics for tiny replacement parts are completely airtight. Having 50 of these specific fans in stock isn't trivial. It is the invisible safety net.
Wow, it really shifts how you look at commercial tech. I think the big takeaway for me is that enterprise systems aren't built to be indestructible. They are built to be quickly repairable.
That is a great way to put it.
Yeah, the 4K video walls get all the credit, but the architecture is completely dependent on anticipating failure and just having the right tiny parts ready to go.
It really is a testament to the fact that complex infrastructure is only as robust as its weakest, most replaceable link.
Right, absolutely. So here is a thought to leave you with today. Next time you are in an expansive sports bar, watching dozens of screens running perfectly in sync, take a moment to consider the 1.2-watt fan spinning silently in the server closet, keeping the silicon from melting down. What other invisible, easily forgotten components are holding together the complex systems you rely on every day?